Factoring again. So, lo and behold, are you surprised that I say today we need to factor? Can we factor x squared plus 2x minus 15? What can it factor as? I shouldn't he try to think of two things that added to give him 2 and multiplied to give him negative 15. He came up with 5 and 3. 5 and negative 3. Okay, yesterday's just said factor. We solved to prove a point for ourselves because we wanted to show that the zeros end up being the opposite signs of the factors. But today I have to solve. Why do I know I have to solve? What word lets me know I need to solve? Because it says the word solution. I mean, somebody's got to solve something. So we set our equation equal to 0. So we're going to have two answers. What are our two answers? Negative 5 and positive 3. Okay, but those are not answer choices. Because we're not done yet. Which one is A and which one is B? Which one's A? And they're correct because we got to have negative 5 is less than 3. Because when we write 3 less than negative 5, well, that's not right. 3 can't be less than a negative number. It has to be A is negative 5 and B is 3. So they ask us to find 4A minus 3B. Well, that's going to be 4 times negative 5 minus 3 times 3. So what should my answer be? Which is A. I'm going to fix that. So, yes, I agree. When I walked around, I didn't see yours out because you answered everything I said. I'm giving you points with orange. Okay, if I was guessing, which guess would I have made? It wouldn't have been A.
Probably C or D.
Which one?
C?
Why would I do C and not D? A lot of them are negative, so I'm going to go with, I get it's either C or D because of the repeat. I'm going with the negative one because a lot of the other answers were negative. I mean, if you're going to guess, make it a good one. Okay, so we've been on quadratics for the longest. And before we were on quadratics, what did we talk about for like years of our lives? Factoring. Years of our lives we've been spending on factoring. Factor this, factor that, factor, factor, factor. Finally, today I'm going to tell you we are not going to factor. In fact, I'm about to teach you something you can do instead of factoring. You can do this instead. In fact, I'm going to go this far. I'll tell you this. I did not know how to use a ninja star until I taught you. Because when it looked hard like this one does, I use the quadratic formula. I don't factor. I use the quadratic formula. But if we were to factor, what's the first thing we should do on this problem? It says 6x squared plus 10x minus 24. We would have to pull out that GCF. And we would end up having 3x squared plus 5x minus 12. And then with our ninja star, we would put the A's there, the B's 5, the C would be negative 36. And we could figure out stuff that multiplies to 36 to negative 36 and adds to 5. I can think of that off the top of my head. Can you think of that off the top of your head? Multiplies to 36, negative 36, adds to 5. It's what you think it is. 9 and 4. 9 minus 4 is 5. 9 times negative 4. I mean, we could do this. One of my factors, this one reduces to 1/3. So one factor is x plus 3. The other factor is 3x minus 4. So our roots end up being negative 3 and 4/3. Or 1.25. Right? Haven't done math wrong today. It's been one of those days where I can't seem to do math. No, that's correct. Okay, and that's great. And in the real world, on a real standardized test, if Gavin has the choice, since he's good at factoring, factor away, dear. Factor, factor, factor. But as you can tell from your color by number, the directions say use the quadratic formula. So even though things look like you can factor them today, you're more than welcome to check with factoring. But you must actually, to get your points, use something called the quadratic formula. Okay, and then before we go talking about quadratic formula and I sing my song, because there is a song, can you tell me what standard form was again?
AX squared
Thank you.
plus BX plus C.
Yep.
Yeah.
And then so before we even go into what this formula says, before we even get into this monster and why he might be more useful than factoring in some ways, before we even go into that, let's just start with the basics. We're given this example. What is our A? What is our B? What is our C?
A is 6,
B is,
10.
C is. So see, so far this seems really easy. So far, so good. In fact, some of us are going to think the quadratic formula is way easier than factoring. You don't actually have to come up with stuff on your own. You're just what I like to call plug and chug. You're just plugging numbers in, chugging out an answer. Pretty simple. The hardest part of the quadratic formula is remembering the quadratic formula, because it has a lot of things going on. So let me pause my video because I refuse to be syncing on YouTube. I will post, because Lord knows we don't need that on there. Okay, so if we've got this formula, we can plug in the numbers and get out an answer. But I swear I want to come back to that. I know you think I'm crazy, but I want to come back to that in just a moment. I want to now go to the purple sheet. Okay, so we're looking, I'm going to have both on the screen at the same time. The purple sheet is talking about something, and it's specifically called, the name of it is called the discriminant. It's a useful term to know in life, discriminant. If you can calculate the discriminant, suddenly you'll figure out why the quadratic formula is useful. Do you see that discriminant somewhere inside this quadratic formula? Where is the discriminant? It's underneath that radical. It's under the square root symbol. So the discriminant is the thing under the square root. If you calculate it and go ahead and figure out a number, depending on your number, that's going to tell you about those zeros of your graph. So, and if we look at our notes, it tells us this. If when we calculate this thing, if we get a number that's bigger than 0, so a positive number, we have two real solutions. Our graph is going to cross that x-axis twice. If we calculate this thing and we get something that's equal to 0, we're back to that double root world where we have only one solution. We only touch that x-axis once. And then if we calculate this thing and we get a number that's less than 0, we have no real solutions, which you talked about meant the graph didn't cross that x-axis at all. So let's just look at it one step at a time. So I need to calculate b squared minus 4ac. What is b in my first example? You need this? Yes, dear. Okay, so it's what? Negative 8. Negative 8 squared minus 4. What is a? And then what is c? Okay, be very careful about your signs today, because Lord knows they matter, especially for this.
Hold up. Why? Hold on.
So we did b squared. We plugged in b as negative a. Minus 4, and then a is 2. C is negative 42. We're plugging stuff in. This is the B, this is the A, this is the C. We could even color code it if we wanted. B, B, B. A, A.
Miss Compton?
Yes, ma'am.
Would you send Will Browder to Miss Billings' office?
Yes, ma'am.
505?
Yes, ma'am.
Thank you.
See. We can color code it if you'd like. Okay. Is there anyone who's like magically lost now? We're just plugging in the things. That's the B, A, B, C, like usual. We did B squared minus 4AC. For some reason, Ms. Compton is telling us if we calculate this, we're going to know something. Okay, negative 8 squared would be positive 64. You did negative 4 times 2 times negative 42. What did you end up getting?
Negative 330.
You did negative 4 times 2 times negative 42. And you got a negative? Positive what?
330.
And then you add 336 and 64. Again, a negative times a negative, you know that's positive. That's why I'm calling him out on it. He knows that. It's important today. 64 plus 336, you get
400.
400 on the nose. Okay, is that number bigger than 0? So we know that's bigger than 0, so that means if we were to graph it, I don't know where those two roots happen, but it's going to have 2 of them. I know that much. Okay, and then let's go to the next one. We're going to do the same thing. B squared minus 4AC. What is my B? Assumption don't answer anymore for me. Okay, minus 4. What is my A? What is my C? Okay. I need to know negative 18 squared. Well, what is that? And then 4 times 3 times 27.
What does it mean, negative 4?
It is negative 4. Bless you.
So then it'd be negative 12.
Times 27. Which is?
Negative 324.
So we got 324 minus 324. What do we end up getting? 0. So we're not bigger than 0. We're not less than 0. We're equal to 0. Our discriminant, that's what this thing is called. This B squared minus 4AC is called the discriminant. Since our discriminant is equal to 0, we have exactly one solution, which means our graph crosses that x-axis exactly one time. We called that a double root. We talked about it might be, for instance, x minus 3 squared. It might be one of those special products. But to calculate the special product, we actually had to factor and do some work. Is this really work? We're just plugging stuff in. This is really, there's not a lot of brain required like there is with factoring. Okay, and then let's do this B squared minus 4AC one last time. So my B is, my A is, my C is, no more Riley. Okay, so I have 81 minus something. 81 minus 128 is, okay, that's less than 0. So if you get a positive number, we've got 2 real roots. You get 0, we have exactly 1 root. You get a negative, we have no roots at all. So what does that mean about our graph?
It's not there.
Oh, it's somewhere.
It's
It
under.
doesn't touch the x.
It cannot touch that x-axis. It's still a parabola. It just cannot touch that x-axis. It could be like this, or maybe it's down here like this. But regardless, it's not crossing that x-axis. Cannot cross it. And you and I, when we were factoring, we wrote some things are not factorable, yeah, but we don't necessarily know for sure that means they don't cross the x-axis. Factoring is not all it's cracked up to be. Sometimes factoring leaves me a little confused, and I don't know what my answer really means. Whereas with the discriminant, it's very crystal clear. You get a number that's positive, you've got 2 roots. Get a number that's 0, you've got 1 root. Get a number less than 0, no real roots. Okay. Pull back out your yellow thing. And have out your monkey at the same time. Your monkey. Let me preface, based off third period, because they're so smart like you, let me preface with this. My two examples are super easy. My two examples are just for us to prove to ourselves that this formula is easy and we can use it. I'm going to get nice, pretty numbers on mine. I'm going to get like square root of 144, which is 12. Or I'm going to get perfect squares and pretty numbers. Do you think you're going to get all pretty numbers based off the color choices for the monkey worksheet? No. You are not. That's why we like this quadratic formula. Because it can do the hard ones that we've been just kind of skipping, or Miss Cobbins has been leaving off out of our lives. Now, again, I get Trey is very smart. And maybe on number 10 he realizes, hey, I can pull out a 6. And that would be x squared plus x minus 3. That's an easy factor. I can do that. That's great. Trey can check himself like that. But again, the directions for this color by number are to use the quadratic formula. The good news is we're going to spend today and tomorrow on it. Dear.
How do I do this little plus sign, the negative sign? How do I do that?
We're about to get there.
Yeah, but I'm already there.
I know.
I don't know what to do.
Well, let me finish my words and I'll be there. So, again, Ashanti's trying to skip ahead to the ending. Good for him. If he does not show his work using the quadratic formula on my monkey, he will not get his points. In fact, to make sure Ashanti shows his quadratic formula at work, I'm going to put it in the 30. I'm going to put the monkey color by number in the 30. So if you color it and you get your coloring bonus or whatever, you would get a coloring bonus in the 30. Whoa. Okay, so we've got this formula. It's negative b plus or minus square root. Ashanti wants us to figure out how to plug it in. So let's look at ours. So it's negative b, so negative 10 plus or minus square root. B squared, what would be squared? What is that?
10 squared.
10 squared minus 4ac. So what's a?
6.
C?
Negative 24.
Maggie, you're out. All over 2a. What is a? Okay. Are there any questions about that?
40 what?
What, baby?
4, 6?
Yeah, 4 and 6. Here, let me zoom in. Okay. You realized, for instance, on your monkey, on number 6, it's not equal to 0. So you have to subtract 10 first to set it equal to 0 before you pick your A, B, and C. So you probably want to make a note to yourself on your monkey. Set equal to 0 before picking A, B, C. Let me say my words again. Because when we wrote down that standard form, we said ax squared plus bx plus c equals 0. In standard form, we had equals 0. So on our worksheet, we need to before we even try using that quadratic formula. Now I can pick my A, B, and C. It would be 3 is A, 9 is B, negative 12 is C. Before, if Ashanti didn't move everybody over and do what he was supposed to do, he would have picked negative 2 is C, and he's already off to a bad start. The hardest part of the quadratic formula is to remember it and plug the right people in the right places. If you can do those two things, it's a piece of cake. Okay, back to the worksheet. I mean the yellow notes. Step 2, so we did step 1, we identified A, B, and C. Step 2, we substituted in. Step 3, we need to solve. So now we actually get to do some math. What is 10 squared? Anybody, even if you were out before, you can be back in now. 100. I need to know negative 4 times 6 times negative 24. Is it 576?
Yeah.
Is it negative or positive?
Positive.
It's got to be positive because we have this negative 4 and the negative 24. They may end up making a positive. Negative times negative makes a positive. I know it's teeny and tiny, but that tiny sign error is going to change our whole answer. And then 2 times 6 is 12. Okay, any idea what our next step should be?
Add like 10.
Okay, so what will we have under that radical then?
6, 7, 6.
Okay, and then let's go one step further. What is the square root of 676?
Good question.
26.
Okay, my examples have perfect squares. Your examples, your color by numbers obviously does not have pretty perfect squares. You type in 676, you get the decimal, you write that down. It might be you get 5.2, so you put negative 10 plus or minus 5.2. You do not have to have perfect squares. In fact, you're not going to have perfect squares. Mine are nice because they're my examples. Life is hard. And now we get to finally handle the mystery that Ashanti is wondering about. What is concerning you again, dear? Tell us what's bothering you. I don't either. Does anyone in here know how to do a plus minus?
You don't know how to do that?
Oh, yes, of course I do. Is there a button for a plus minus at the same time?
Yeah.
No, that's just to change the sign, dear.
The plus can end the minus.
No. Okay, remind me, what's special about quadratics? How many roots do they normally have? So right now it looks like we're getting one answer. That plus minus is how we're going to get two different answers. We're going to separate it now. We're going to do the plus. And we're going to do the minus. So how do you deal with a plus or minus? You don't. You break it up. You do a plus. You do a minus. That's how we get two answers, because the plus minus really is standing for two different things. Okay, so we actually do this way, and we get 26 minus 10. That's 16 over 12. What does that reduce to? Reduce the fraction for me. 4/4. Hey, isn't that what we got before when we factored it? That's what I have. I have 4/3.
Wait, huh? I'm sorry, what?
16 over 12 reduces to 4/3. Reduce your fraction.
Wait, where did we get that? That's what I'm making.
26 minus 10 is 16,
Alright, and then over.
because there's 12 in the denominator. And then in the next one, so I've got one of my answers. I got 4/3. Hey, that's the same number we got when we factored. I bet we're also going to get -3. Let's see. -10 minus 26. What should I have in my numerator? -36 over 12. What does -36 over 12 reduce to? -3. So lo and behold, we got the same two numbers we got when we factored. And while I'm showing all my work now, because my gosh, this is the first time we've seen this bad boy, you can see how it's a lot less work, a lot less mental work. It's mostly just bookkeeping. Can I keep up with this and do easy math? So we plugged the stuff in. We did 10 squared was 100. We did -4 times 6 times -24. We got 576. We combined the two under the radical. We got 676. We typed in square root of 676. For us, it ended up being a perfect square, so it was 26. If it's not a perfect square, don't quit. It's okay. Write down the decimal. Keep going. Then we had to tackle that mysterious plus minus. Like the Red Seas, we had to part it. The plus with one answer, the minus with the other. We combined 26 and -10. We got 16. We reduced 16 over 12 to 4/3. We combined negative 10 and negative 26. We got negative 36. Negative 36 divided by 12 was negative 3. Are there any questions about how this worked?
No.
But how did you get the books?
No, man.
The 26 square root of 676 is 26.
How did you get the 676?
100 plus 576.
Just making sure.
Okay. And then now I'm going to blow your mind.
Why?
Because I can.
No.
We were just talking about the discriminant. If the discriminant was negative, we would end up having a negative underneath the house. We don't know how to deal with that. That's why there's no solution. That involves imaginary numbers. So if you get a negative underneath the house, that'd be a negative discriminant. You're done. No solution. If you get a 0 underneath the radical, so if the discriminant is equal to 0, this would go away. So the plus minus would go away. The plus minus goes with that house. If there's nothing under the house, there's no point for the plus minus. So there would only be one answer. I'll say all those words again tomorrow, I promise.
What was the other one?
If it's negative under the square root, you don't know how to do that. If you got negative square root of 676, we don't know what to do with that. We're done.
So we just leave it.
Yeah, and we say no solution. But again, back to make sure you didn't make a sign error before you just start assuming no solution. Because no offense, you probably made a sign error. Okay, let's do the next one. I swear I'm making life way too hard. It's really as easy as it gets. What is A? What is B? What is C? Negative 1, 3, and 10. Perfect. And then we have x equals, I need negative b, so negative 3 plus or minus square root b squared, so 3 squared, minus 4, what's my a, c, all over 2a. Are there any questions about this? It is his own step because that is the hardest part. I can probably, if Jameson makes a mistake, I can probably look on his paper and see where he didn't plug it in the formula correctly. Are there any questions about this? Okay, so I get x equals negative 3 plus or minus, and then I have 9, and I don't know, I should know. Thank you, dear. What should I get for the next thing? Yeah, is it positive or negative?
Positive.
It's positive. I have positive 40 because negative 4 times negative 1 times 10 it ends up being positive 40. And what goes in my denominator? Negative 2. Are there any questions about that dark brown step?
No.
Okay, and then what should I do?
You can do the little thing.
Split them up.
I don't want to split them up yet. I've got a little more math that I can do first. Let's combine some like terms. So under the radical, what should I have? Okay, and I can simplify that, can't I? What is the square root of 49? Do not part the Red Seas. Do not part the Red Seas until there is nothing else you could possibly do. You tried, it's seriously like Moses in Egypt. You tried, you warned the Pharaoh about all the plagues, you did all of the math you could possibly do before you part the Red Sea. I can't even begin to explain that one to you. Now we'll deal with the plus or minus. I can't actually deal with the plus or. Is there a question with the purple step?
I don't really know.
No.
No.
Square root of 49 is 7. That's all I did from heat purple. And now I've got to deal with that plus minus because I have no other alternatives. So I do the minus with one, and I do the plus with the other. So negative 3 plus 7 over negative 2. Negative 3 minus 7 over negative 2. What should I get for my first answer? Yes, because I have 7 minus 3 is 4. I have 4 over negative 2, so that is negative 2. What should I get for my second answer? Say it again. Is he correct? Okay, because we get negative 10 over negative 2 and it ends up being positive 5. I made the exact same mistake last period. Someone had to call me out on it. That's funny. Again, the only way you can make mistakes with this thing is to be a bad secretary. And if Shanti's magically lost that sign, his negative sign disappeared. He didn't copy it like he should have. That's the only way he can really mess this up. You have a monkey to work on. The good news is you're going to have today and tomorrow, but I'll use my words again tomorrow on the monkey. If I were you, I would try 1, 6, and 8. For sure 1, 6. If you chicken out on 8, it's okay. We can deal with it tomorrow. Y'all smile.
1, 6, and what?
8. They're circled on the screen.